Hey students, in this video I'm going to go over the introduction to Focus and Directrix. And we started with an activity in class where I asked you to write a line, just draw a line, and then write a point above that line. And then I asked you to fold the patty paper where that dot aligns with the line and then crease it like this. And then I asked you to move that dot down the line and keep creasing it over and over all the way till that dot lines up all the way to this end of the line. And then after that, I asked you to now go the other way and then continue creasing it all the way till the dot gets to the end of the line. So it's an activity that is used for the topic that we're learning. As you open this, you will notice that it created like a parabola. And then we talked about that every parabola has a vertex here. And what you are learning in this lesson is that this point right here is called a focus. And this line underneath the parabola is called a directrix. So it's a visual representation to understanding whether the parabola is sideways, that the focus is inside the parabola and the directrix is outside. Even if the parabola is upside down, the focus is inside the parabola and the directrix is outside. Same thing with the parabola opening sideways and then above. So it's just a visual to help you remember that the focus is a point that you have to use or find. And a directrix is a line that it's sometimes written as y equals if it's a vertical line, and it's written as x equals if it's this is a vertical line and then horizontal line. So when the parabolas are sideways, you have a vertical directrix, and when it's up and down, you have a horizontal directrix. Okay, so with this visual, we are going to practice finding the focus and directrix. So the notes just specify the two vocabulary words, focus and directrix, and focus is a point and directrix is a line. And whether you have a vertical parabola or horizontal parabola, you have the same relationship happening. The thing that you will have to calculate is the letter P, and P will be considered the distance between the vertex and the directrix, along with the distance between the vertex and the focus. And you could see that here on this paper, the distance that we had from the focus to the vertex, this distance is the same distance from the directrix to the vertex, because again, we folded the paper and aligned them and it created the same distance. So that distance is your P. The P is the distance from the vertex to the focus and the vertex to the directrix. So if you don't have the P, you have to calculate it. And the way to calculate it is following this formula. P equals the absolute value of 1 over 4a. So absolute value will always give you a positive answer because you're just finding the distance. So if you want to memorize just 1 over 4a, that's fine. So here's a couple of examples in class that we did. The first one, we identified the p-value. So absolute value of 1 over 4a. And the a was your negative 1/8. That was the a value. So then we're going to write absolute value of 1 over 4 times negative 1/8. And if we use the calculator just to speed things up, we're going to have absolute value, control divide, 1 over 4, parentheses, and we're going to do negative, control divide, 1 over 8. Enter, and the answer is 2. So this means that the p-value is 2. That's the distance. So we can see the visual that the vertex is here, and we know the distance is 2, but let's just write it down. The vertex here is 2, 1, 2, 1. And we're going to identify the focus point with the distance of 2 spaces. It is open sideways, so if you have this visual, the focus will be on this side and the directrix outside. So 2 spaces, and then this is the new focus, or the point of the focus. Order pair for that is 0, 1. So 0 stays there, and then 1. And then the directrix will be the opposite direction, 2 spaces. So right here, we will have that vertical line. I'm just going to highlight that. And that is the directrix. And because the vertical line, we're going to write x equals the number 4. So the directrix is at x equals 4. The focus is at 0, 1. So the goal is for you to determine the focus and directrix with the information given. So if you have the P and a vertex, you can easily find that. If you don't have the P but you have an equation, you can find the P with the A value of the equation using this formula. Okay, let's practice 2 more times. Here is the, let's see. Yeah, so here's the A value, the 2. And we're going to do P equals 1 over 4A, absolute value of that. So 1 over 4 times 2. And we're going to type that in the calculator, or you could do it by hand if you want. Absolute value of control divide, 1 over 4 times 2. And that's 1/8. So your distance, your p-value is 1/8. That's your distance. So we gotta look at the vertex. The vertex is right here. And that is a -1 on the x and a +1 on the y. So then we have the distance of 1/8. So in class, I kind of taught you a little bit about how to check where 1/8 is. I mentioned that from 0 to 1 on this grid, you count the spaces, and there's exactly 8 spaces from 0 to 1. So that means that each line is already counting in 8s. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and the whole number for that. So if our distance is 1/8, we are simply moving one line above the vertex and one line below the vertex, because the distance is 1/8. So that means that the focus will be this point. That means your x value is -1 and your y value is 1 plus 1/8 because it moved up 1. So in class, we mentioned most of you don't like working with fractions, so we can convert this to a decimal, which ended up resulting in 0.125. And I'll just show you that in the calculator. You can go menu, number, convert to decimal. So it's converting the answer that was there into a decimal. Enter. Or you could also just do, whenever you have a fraction, you could do Control Enter, and it'll turn it into a decimal. So the distance is that much in decimal form, which means that we are going from 1 and increasing by 1.25. So the y value is 1.125. That's the focus. Then you have your directrix right underneath, and it's a horizontal line. And because it's a horizontal line, we're going to write y equals. And then we just got to find out what that number here is on the y-axis. So it was at 1, and it went down by 1/8. So we can say whether we decrease by 0.125. 1 minus 0.125, and that's 0.875. So that's the directrix. Directrix is y equals 0.875. Okay, let's do one more example. We have this one right here. So the a value is right there. We're going to do p equals 1 over 4a, absolute value of that. So 1 over 4 times 5/4. And then let's type that in the calculator. Absolute value, control divide, 1 over 4, parentheses, control divide, 5/4. And then it's 1/5. So 1/5, it's the p-value. And again, that's the distance. And the distance, we can turn that into a decimal. And it'll be 0.2. 0.2. And again, we're going to use the vertex. Let me just write like this. Vertex, that's 0 for the x. And then it went down to here. And I know we don't see it in the paper, but that's -1 right there. It was 1, 2, 3, 4, 4 spaces down, that's 1. 1, 2, 3, 4, 4 spaces down, that's -2. So -1 is the y value. So 0, -1. And then we're going to move 0.2 of a distance this way. It's already written in decimals, 0.2, 0.4, 0.6, 0.8. So 0.2 will just be right here. That'll be the focus. The order pair will be x of 0.2, and the y is -1. So that's the focus. And then the directrix is the opposite direction, 0.2 of a distance. So we go to the left, -0.2. So right here, that's where we'll have the directrix. And because it's a vertical line, we are going to write x equals, and then you just write down where it's touching, -0.2. Okay, so with those 3 examples, this should be enough for you to understand how to find focus and directrix. Go ahead and practice with the 3 problems on the right, and check the key on Schoology.